Hello everyone, I'm Govardhani. In this video, we are going to see about a best first search algorithm in R programming. So let us see what are the topics we are going to see in this video. Initially, we are going to see about an introduction about an uninformed search, an introduction about an informed search, then best first search algorithm, advantages and disadvantages of best first search algorithm, and examples of best first search algorithm. Let us see about informed search. Before that, we are going to see about an uninformed search. So we have talked about the uninformed search algorithm, which looked through the search space for all the possible solution of the problem without having any additional knowledge about the search space. But an informed search algorithm, how far we are from the goal, path cast, and how to reach the goal node, etc. This knowledge helps the agents to explore the search space and find more efficiently to the goal node. Let us see the informed search algorithm in elaborately. It is more useful for the large search space, and it is also the idea of heuristics, so it is called as a heuristic search. So this heuristic is a function which is used in this informed search, and it finds the most promising path. It takes the current state of the agents as it's an input and produces the estimations of the how close the agents it from the goal. The heuristic method, however, might not always give the best solution, but it guarantees to find a good solution in reasonable time. The heuristic function estimates how close to the state is to the goal. It is represented by h of n. So the cost of an optimal path between the pair of states. The value should be the positive in heuristic function. The admissibility of the heuristic function is given as h of n is equal to h star of n. Let us see what is h of n. H of n is a heuristic cast and h star of n is an estimated cast. So the heuristic cast should be less than or equal to the estimated cast. So that why here represented as h of n is less than or equal to h star of n. Okay. Let us see the pure heuristic search. The pure heuristic search is the simplest form of heuristic search algorithm. It expands the node based on the heuristic value. It is an h of n. It maintains the two lists. One is a open. So here as I have given a node of s, which is an open, then closed, then s, it was closed with a successor node of a and b. Okay, let us see about the informed search. We have two main algorithms in this informed search. The one is a best first search, another one is an A star search. So let us see about the best first search algorithm. So the best first search algorithm is also called as a greedy search algorithm. So this greedy search algorithm always selects the path which appears the best that moment. It is a combination of depth first search and breadth first search algorithm. It is uses the heuristic functions and search. The best first search allow to take the advantages of both the algorithm. With the help of the best first search, at each step we can choose the promising node. The best first search algorithm, we can expand the node which is closest to the goal node. The closest cost is estimated by the heuristic functions. So f of n is equal to g of n. This here h of n we have already said as an estimated cost from the node n to the goal. Let us see about the algorithm of best first search. Okay, the step one, we have to place the starting node into the open list. So I have given as a starting node which is open, and then we have to know if the open list is empty, the stop and return failure. We have to check whether the node is empty or not. Okay, so here I have given a starting node S which is now open. Then if it is open, so we stop and return failure. The step 3, so remove the node n from the open list which has the lowest value of h of n and place it in the closed list. So we have to find out whether it is a closed or open. So if it is a closed, so if it is a closed node, we have a successor node for starting node of A and B. Then we have to know the lowest value of h of n. Here the lowest value of h of n from starting node to the successor node is s to A. Let us see about the step 3. So expand the node from the lowest value of h of n. So and we can generate your successor node. From starting node to your successor node, so the lowest value of h of n is a 3. So from S to A, then we have to find out any other successor node is there for the node n, whether if it is a closed or open. If it is a open, it can be stopped and written for your failures. If it is closed, we have to find out the lowest value of your successor node. Here the lowest value of the successor node is a 1 from A to D. Until this process that can be repeated to reach your goal. Let us see your step 5. So from S to A, yes, starting node, we have a successor node is A to B, and find whether any node is a goal node or not. If any successor node is a goal node, and return success and terminate the search. Else you can proceed to the step 6. Let us go for the step 6. So we have for each successor node algorithm, check for the evaluation of n and check if the node has either an open or closed. If the node has not been in the both the list, then it add to the open list. So in this tree, so S is my starting node. So then after starting node, we have whether my node is a closed or open. So if my node is a closed with a successor node, then we have to find out the lowest value from the starting node. Here then my lowest value from the starting node is from node A. So that is the lowest value of 3. Then we have to know whether the node is a open or closed. Again my node is a closed with a successor of C and D. Then we have to find out the lowest value of that node. So here from A to D is the lowest value. Then from D we have to know whether my node is a closed or open, or otherwise it is going for the goal state. So here my D to E is my goal state. So we have to move that position. So this is the, so if step 7, if it is open and return, stop and return for your failure and return for your step 2. Let us see the advantages and disadvantages of breadth first search algorithm. So it is a switch between breadth first search algorithm and depth first search algorithm. It is a more efficient than breadth first search algorithm and also a depth first search algorithm. Well, let's move on to the disadvantages of this breadth first search algorithm. It is an unguided depth first search algorithm. It also stucks in a loop. This algorithm is not an optimal. Let us see the simple example I have given here for the best first search algorithm. Here I have given a node A which is open. So whether we have to check whether the node is opened or closed. If it's open, we have to stop and return for the failure. If it is closed, we have to check whether any successor node of your node A is there or not. So check the node A has a successor node not. If yes, the node A is closed, or else the node A is open, then return and failure. Then we have to check the lowest value of the each and every successor node. Here the lowest value of the successor node is 1. Then we have to expand the node from D to from successor node. Let us move on to successor node from D. So we have another more successor node that has been expanded from the node of B, that is G and H, and D from E and F. From the successor node, we have to find out the lowest value. So here the lowest value is 4. So from the E node, we are going to expand the node until we are going to reach the goal. So again, I am going to expand the node from E. So that is I and J. So J is my goal node. So exactly we have to move to the goal node. So this is a simple example I have given here for best first search algorithm. So here the optimal solution of my tree is from starting node A to I am moving for D, then I am moving for E, then I am moving for J. This is the optimal solution of this tree. Let us move on for the another example. I have given here as a tree, a starting node A and my goal node is J. So I have given from all the node which is connected. So then here I didn't specify any values for this node. So Next slide. Here I have given the each and every value for each and every node. So B for 5, C for 6, D for 1, and again the B that has been expanded to G and H. There I have given a 6 and 5, and D that has been expanded with E and F. I have given a 4 and 6, and E expanded with another two nodes 10 and 0. So my optimal solution of this tree is, so from starting node we have to find out the whether the node is opened or closed. It is defaultly it is a close. So then we have to find out the lowest value of the particular node. Here the lowest value of the particular node is D. So again we have to move to the D. So then from the D node we have seen any successor node is there or not. Yes, there is a successor node. So B also we have a successor node, and D also we have the successor node. From the all the successor node of B and D nodes, we have to find out the lowest value. Here the lowest value is E. Then from D node to we have to goes for the E node. Then from E node we have to know whether it is can be reached for the goal state or not. Is the E portion that is reaching for your goal state. Let us see this example. What are all the nodes that has been closed? What are all the node that has been opened? So the open list is B, C, F, I. The closed list is A, D, E, G. Okay, so let us summarize all those things what we have seen in this video is introduction about an uninformed search, an introduction about an informed search. In this informed search, we are going to see only about an best first search algorithm, advantages and disadvantages of best first search algorithm, and examples of best first search algorithm. Thank you.